Hi, this is John Hansen, and I'm here to give you a quick introduction to using Spartan Student version 6, just enough to get you started. We'll focus on how to build molecules. So once you start up your Spartan, like we have right here, you'll see this screen with all these little icons. And the first thing you need to do to get building your molecule is to go into one of these two icons, either the build mode or the sketch mode, and we'll talk a little bit in this video about the difference. But let's start off with the new build mode, and when we click on that, you'll see we get sort of this palette to the right with lots of different atomic fragments that we can use to build. So let's pretend we want to build acetone. I guess we don't have to pretend, we'll actually do it. Let's take a sp3 carbon, we click on it, and then when we click in the window, it automatically builds an sp3 carbon for us. Then acetone has a carbonyl in the middle, so I'll take an sp2 carbon and put that in the middle. And then I'll put another sp3 carbon at the other end. Notice that I haven't put the oxygen in the middle. It just has kind of this little stubby double bond with this little dot at the end. So we need to put an atom there. And so I'll put an sp2 oxygen with double bond right there. And I've got my acetone. Now when you build it, these little stubs here are called free valences in Spartan, and when you start to work with the molecule, they'll automatically be turned into hydrogens if you don't add anything else there. So we've actually got our acetone built right here. Now when we built it, it was just like a set of simple molecules, simple fragments that had bond angles of exactly what you'd expect from VSEPR. So if this is an sp2 carbon, as we mentioned, the bond angle should be 120 degrees. We can check that by going up into the geometry menu item here and select measure angle, and then we just click the three bonds that are the angle we want. And when we click those, down in the right hand corner you can see that it says 120 degrees. So that was exactly what we expected for sp2, and of course we can check any of those bond angles, and that's 120 degrees. Now of course in the carbon on the ends, those are sp3, so what bond angle do you think that will be? Well, let's find out. We'll just click on those three, and sure enough, probably what you expected, very close to 109.5 degrees for those bond angles. So this is a very simple way of building things, but in the real molecule, the atoms and those angles will deform, and the bond lengths will change in order to accommodate those different groups in the molecule and steric repulsions that they might have between them. So in order to sort of take that into account and to see what the molecule, a more realistic view of what the molecule might be, we're going to do something called energy minimization, and specifically we're going to do molecular mechanics energy minimization. It's very fast. It just treats each bond sort of like a spring, and it has sort of what ideal values of bond angles are and how much energy it costs to distort them and many other parameters in it. But it's all sort of classical mechanics, and it's a very quick calculation. And it's not perfect, but it gives you a pretty good estimate, or at least an initial estimate of the molecule's shape. So we can go down and click this little sort of jaggy arrow here. You can also get it by looking under the Build menu and selecting Minimize. So I'm going to click that, and boom, it did the minimization in less than a second, and the molecule changed a little bit. Now, if you want to see, did those bond angles really change, I can go again up to my geometry menu and select measure angle again. And now I'm going to click, and remember this was 120 degrees before, but now it's slightly different. It's about 117 degrees. So these guys have actually moved a little closer, and then the oxygen-carbon distance has gotten larger. It's now almost 122 degrees. So the molecule has adapted for the different atoms that are around it. These sp3 carbons, now they're probably no longer 109.5, so let's check. Let's see, that hydrogen bond angle is now 110 degrees. Here's another one. How about the carbon-carbon hydrogen bond distance? Oh, that's about 109.6, so that's pretty close to what it was before. But the whole point here is that whenever you build a molecule, you should always hit the minimize button so that you get sort of a better, a more accurate representation of what its shape really looks like. And if you built it in some funny shape where it's kind of running into itself, it'll fix that when you do that calculation. One other thing I want to show you about the molecule is the different views that you can have in Spartan. So this is called a ball and stick view. And if we go out of the builder mode where we have this little palette, you can click this little eyeglasses and that'll take us to the view mode where it'll close out that palette and we'll have more screen real estate here to deal with. If you go up under the model menu, you can select different ways of displaying it. So we've got wire, ball and wire, tube. Tube's one of my favorite for complex molecules. You can see how it's just simplified them to sort of these just little lines, sort of like a line drawing that an organic chemist would do. Another popular view to look at is the space-filling molecule or model, which shows you sort of what the size of acetone really is if you thought about like how close together they could get to each other. This is about the size of the acetone molecule, whereas our ball and spoke doesn't really give us that quite same feeling about what the real size of the molecule is. Most of the time, though, people work in the ball and spoke view. It makes it easy to see where the atoms are and kind of the geometry. So we'll leave it there for right now. Okay. When we did our molecular mechanics calculation, it didn't know anything about the electrons and where they are really. That would be something that we would have to calculate from quantum mechanics. So for example, if we would display the properties of this molecule, you can see that it has lots of things. It already knew that it was acetone, even has the CAS number, has the formula, the weight, etc. But if we look down here, you can see it doesn't know anything about the HOMO, the highest occupied molecular orbital, or the LUMO. That's why it's pending, and it doesn't know anything about dipole moments, etc., things like that. So if you wanted to learn something about those properties, things that were influenced by the electron distribution, you'd have to do a quantum mechanical calculation, and Spartan can do that quite easily, although it takes a lot longer. If we go to Setup Calculations, we bring up a new window which has a number of different options for us. The equilibrium geometry is what you normally want to do. It's sort of the same as minimize. It says find the kind of lowest energy from where you started. Hartree-Fock is a sort of approximation that's used for doing the quantum mechanical calculations. If we click on that, you can see there's molecular mechanics. That's what we were doing. So if I clicked on that, that's essentially what we were doing when we were hitting that minimize button. And then we have different levels of theory here, starting from the lowest level, sort of quantum mechanical theory called semi-empirical, Hartree-Fock, P3LYP. We won't go into details of what those are, but by default, the calculation window comes up with Hartree-Fock 321G, which is sort of the lowest level quantum mechanical calculation that most people would be interested in using. So let's go ahead and submit this job. Don't just say OK or it won't do anything. So we'll submit that calculation. It'll bring up a window where we're going to stave it. Notice that it's called acetone because it already knew what the name of that molecule was. We could change that if we want, but I'll just leave it. And we'll say save, and it'll now submit our calculation. Now, remember what it's doing now is trying to solve Schrodinger's equation with certain approximations. And boy, it's pretty fast. It's amazing how fast computers are now. Now, if you look at it, it might not look that different from what it looked before. We could check that bond angle. Let's see here. If we go to geometry and say measure angle, and we do those three, oh, it's 115. Remember before with the molecular mechanics, it was about 116. So it has changed a little bit, the geometry using this quantum mechanical calculation. But more importantly, we can now get electronic properties like things like the dipole moment. So if I bring up this, by the way, this was under the display properties category. If I display properties, now you can see I've got HOMO energies, I've got dipole moment, and if I click on display dipole vector, there it is. That's probably just exactly where we expected it to be. That carbon-oxygen bond is very polarized, and so we've got the minus on the oxygen and the plus on the carbon, and we have a nice dipole moment right there. So you can also show lots of other surfaces, etc. We won't go into that right now, but I did want to sort of point out the fundamental difference between a quantum mechanical calculation, where you can get information about orbitals and electron distributions and things like that, versus molecular mechanics, which just sort of gives us general shape information, which is oftentimes what we might be interested in. Okay. Well, that was doing things, building a molecule using the build mode. Now I want to show you how to build a molecule in the sketch mode, and we'll do acetone first, just a way to try it. So let's get rid of this molecule. There's two ways that we could do it. We could hit this icon, which would close the molecule, and then we could save it if we wanted to. Or if we're just done with it and we never want to look at it again, we can go up under the edit menu and just say clear, and it'll just clear the screen. And it's very nice. It has to make sure you don't do that accidentally, and say okay, there it is, and I'm back in my build mode. But now I don't want to do it with the building using these fragments. I want to do it using a sketch. So I'm going to go to the pencil icon, new sketch, and click on that. And now you see we get a different looking palette. It's got various atoms here and rings and groups, and we can start building a molecule. So let's start with acetone. We want carbon, and we want a carbon-carbon bond, so we just click and drag. There's a carbon-carbon bond. We can click and drag to make another one. This is sort of like a line drawing that you would do in organic chemistry. And now we want in the middle a bond to oxygen, so we go pick the oxygen, and we click from the carbon out, and we'll put an oxygen. Now it thinks we want a single bond, so it automatically did an OH, but we would like a double bond there, so we're going to just click and drag over it again. This is a little different from ChemDraw, but you'll get used to it. You just click and draw over it to make a double bond. So there's our acetone. Now this is just a 2D drawing like it would be in ChemDraw. So now what we would like to do is see the 3D view, and all you have to do is click the eyeglasses again. That'll take you back to that build, to the view window, and there it is. That's the new acetone we just built. And notice, well, maybe it's a little hard to notice right now, that it's actually done the minimization for us. We can check that by checking the geometry, measure angle, and if we click those three, there's that 116.7 degree angle we saw before from the molecular mechanics minimization. So that was pretty easy to use. Sketch as another way to build the molecule. Let's now see if we want to maybe take on a little bigger challenge, a slightly more complicated molecule, and how we would build that. So I'm going to flip over to this other screen here, where in ChemDraw I've drawn this molecule as just something interesting to try to build. And we'll try to do it both in the build mode and the sketch mode and see which one we like more. And again, it's sort of personal preference, although in some cases one works better than the other. And so sometimes I'll try to use the sketch, sometimes I'll use the build. It just depends on, you know, what I think is going to work a little smoother. Okay, so let's get ourselves oriented. We need a 6-membered ring with a double bond and an oxygen in it. Then we need an aromatic ring, and we need an amide group. All right, let's go back and build it. Okay, so we have this molecule. Let's say this is something we want to keep working with. We can go ahead and make a new build by clicking on this little new build icon here. And it brings up another tab down here where I'm building a new molecule. Okay, so we're going to a 6-membered ring with an oxygen and a double bond on it. Let's start with that. Well, we could build it by taking a bunch of fragments like this and building them around. That would be pretty complicated. So Spartan has helped us out by having a ring menu. So if I click on that, and you can see it's sort of defaulted to benzene, which we'll want later, but I'm going to start with a 6-membered cyclohexane ring. Now it doesn't have like a ring, even like a cyclohexene or one with an oxygen in it, but I can modify the cyclohexane. So I'm going to start with that and click in the window, and look at it, just builds that cyclohexane just like that fast. All right, now let's see, we wanted that to be an oxygen atom. So that's really easy to change. If we just go and select another oxygen atom of the same hybridization and double click on it, it just automatically changes it to an oxygen. So that was easy. Now we would like a double bond here. How do we do that? Well, the way we're going to do it is we're going to use this little make bond tool over here, and then we're going to click on 2 of these free valences, as they're called. They would be hydrogens if we went to do a calculation on them. And if we click on them, when we click on those 2, it'll make a bond between where those 2 are. So like I could make a bond from here over to here, which I don't want to do, or I could make a bond from here to here, which I do. And so now it's put a double bond in there, although you can't really tell. But it's really a weird geometry. So to fix things up, hit your little minimize button, and there everything kind of flattened out the way we wanted, and having that sp2, that pi bond there. Okay, so we've got that central ring built, and now off of this position, remember we wanted an aromatic ring. So again, I can go and select my rings tool, and now select benzene, and I just click there, And it just pops that whole benzene on. Now, I want to notice something here. Notice it has this little arrow here. That's where I built that new bond. That means I can rotate around that. So if I go into this gray area and I click and drag, notice that aromatic ring, that one I just put on, I can rotate around it to get, if there was a geometry I wanted to look at, that would put it in that geometry. Of course, when I hit the minimize, it'll go to wherever it thinks it's best. Let me try that. Okay, so that's where it likes to have that phenyl ring. And now, over on this side, remember we wanted an amide group. And I could use these tools right here to build an amide group, and that would be fine. But Spartan, again, has made it easy for us by having a number of groups to find. So if I click on group, you can see here it's got the amide group already up because I've been playing with this before. But I can look and see all the different groups it has. It has alkynes, it has azides, it has carboxylic acids and esters, it's got nitro groups, etc. So I've got a number of different groups here. And if I just want to build an amide, I can click on it. When I look at the little picture of the amide that I'm going to build, it's got a little dot on it. And that dot tells me where it's going to connect to the structure. So I could connect it to the nitrogen if I wanted, or it could be in that stereochemistry if I wanted it at that position. But I want to click and have my amide connected there, so I make sure that's selected. And then I just click at the position I want to put it. So there's my oxygen, so I want the amide right there. And boom, it builds the whole amide in one fell swoop. So that's pretty slick. Remember to do your minimization when you're done. And that's that molecule. So it didn't take too long to build a pretty complex molecule in Spartan. Well, now we'll compare it in the sketch mode. And I want to show you one other last thing as we do that, is remember we've been using these tools, the so-called, and I'm going to show you under the file, the so-called new build and new sketch modes, which have built whole new molecules and opened up new tabs down here for each of them, and I can go between them just by clicking. There was our acetone that we had built. There's the one we've built right now. This was an acetone I had built earlier. It's not even there now. So, I can toggle between them. They're in separate spaces. But I can also build a new molecule or sketch a new molecule that's sort of in the same workspace. Now I'll be able to see them differently and go between them, but there will be a lot more facilities in Spartan that we'll learn about later for comparing them. So if you're making a series of molecules and you want to compare them to each other, then usually this other way of building the new molecule is a little more convenient. And so I'm going to show you that. If I go under File, I show you the new build and the new sketch, but down below there's this build new molecule and sketch new molecule. And both of those will put a new molecule in the sort of same workspace, which makes it easier to compare them. So I'm going to sketch the new molecule because we've already built this one and I want to sketch one. So let's see how we do it. So remember, we're going to sketch that same molecule, so we want a six-membered ring. Just double click in the window. There's the six-membered ring. We wanted an oxygen in that ring, so I just double click on where I want the oxygen. I want a double bond here, so remember if I want a carbon-carbon double bond, I click on the carbon and I just drag over the old one and then it makes it a double bond. I wanted an aromatic ring here, so there it is, and I just click and drag and we'll add the aromatic ring. That's not any problem. And it also has a few groups listed here like an amide, so I can just click and drag off there to build the amide. So that didn't take very long at all. And then to convert it to the 3D structure, I just click on the build, and there it is. And you might say, well, are you sure that's it, or is that the one that you built before? Well, when we do this build new molecule or sketch new molecule, I said I put it in the same workspace. So I didn't get another tab here, but what I did get is this guy gets activated, and I can move between the molecules by clicking one direction or the other. And I could have 20 molecules in here and toggle between all of them. And so it's really quite convenient to look at them and move between them when you have it in this mode. What's really going to be the reason why we wanted them is later on we'll learn about using the spreadsheet mode, and then we can add energies for all of them in a big spreadsheet, whereas if they're in different tabs then we can't put them in the same spreadsheet like this. So this gives us a nice way to compare things. Well, okay, I think that was probably plenty for one little video to kind of get you going and building molecules. But of course there's a lot of things we haven't had time to talk about, and a lot of other subtleties of Spartan that you might want to learn about. So I want to point out where you can pick learn these, and that's under the Activities menu on at least on the Mac, it's a slightly different menu on the PC, but you'll find it up there. And just click on them until you find one that says Tutorials. And if I click on Tutorials, it brings up a list of hyperlinks to actually PDF files, and these are essentially the manual for Spartan Student version 6. The first 3 are the ones that you should work through. So walking through Spartan is a simple one, like how to click and how to zoom and move molecules around and that, rotate things, etc., and change the different models. So you can work through that pretty quickly. And then the next 2 are the 2 that I sort of introduced already, the building organic molecules in 3D and sketching organic molecules in 2D. This, of course, goes into a lot more detail than I had time to do. Let's just look at one. If I say building organic molecules, it brings up this window, which is essentially a PDF file, and it's in whatever PDF viewer you have on your computer. And now it's chapter 2, building organic molecules, and it talks about the kit and all the different things that are in it and the different groups that you can build and the rings and everything else. And then it goes through some examples with step-by-step exactly what you have to push to build these molecules, and it gets progressively more complicated as you go through, and it shows you a lot of different tricks for doing those sorts of things. So I highly recommend that you work through these first 3 tutorials that I mentioned that are right here under the activities menu. I'll also notice that there's several others. There's spectra, properties and graphical models. We'll be talking about that. Various other things, organic reactions, and then there's also this topics menu, which is sort of more theoretical background behind how these different things work, and so you can read through those if you want. They're a little more complex than we need to get into right now, but they might be useful for you as you get further into using Spartan. Well, that's it for now. I hope you enjoy using Spartan and get a lot of good use out of it.